Hey everybody, welcome back. Mr. Antonucci here, and in this video we're going to go through everything you need to know for Unit 7 of AP Calculus AB and BC, which is on differential equations. AB students will focus on differential equations, slope fields, separation of variables, and exponential growth and decay. There are two additional topics for BC students, Euler's method and logistic models. I'll cover the AB topics first and finish with two BC only topics. So what is a differential equation? A differential equation is an equation involving a function and its derivatives. So some examples here would be like dy dx equals 3x squared or dy dt equals ky. A solution is any function whose derivative satisfies the original differential equation. The next thing is slope fields. These show small line segments with slopes determined by dy dx at each point. They help you predict solution behavior without solving the actual differential equation. So for example here, if we have y prime equals y minus 1, this is going to have positive slopes when y is greater than 1. It's going to have slope of 0 anytime y is equal to 1, and negative when y is less than -1. Additionally, the value of x is not going to change the behavior of the slope field. So here's an example of what the slope field looks like. And notice as y increases, so do the slopes, but as x increases or decreases, they do not change. AP tasks include matching a differential equation to a slope field, sketching solution curves, as well as predicting increasing and decreasing behavior of a function and interpreting that behavior. Next is general versus particular solutions. General solutions contain that constant, that plus c. So for example, if you have dy dx equals 6x, you're asked to solve that, you take the antiderivative, 3x squared, and you put the c on there. However, particular solutions come from applying an initial condition, then plugging that into the general solution, solving for c, and then writing the particular solution. So for example, that same differential equation with the initial condition y of 2 equals 5 would result in the particular solution of 3x squared minus 7. Another type of differential equation that comes up are what we refer to as initial value problems. These are problems similar to the one we just did with particular solutions. They give you a differential equation and a point, which is going to result in one unique solution curve. So if we take our previous differential equation and the slope field, solve it, apply the initial condition, and then we graph it, this would give you our unique solution curve through the point 2, 5. These are very common types of questions on both multiple choice and free response questions. Another type of differential equation that comes up are separable differential equations. These are differential equations of the form dy dx equals some function of x times some function of y. These can be rearranged into the form 1 over the y function times dy equals the x function times dx. The steps to solve this are you separate the variables, integrate both sides, add plus c to just one side, solve for y, apply the initial condition, and then write the solution. Sometimes applying the initial condition is easier to do before you solve for y, so those two steps can be rearranged. Some common errors here are missing the absolute value if you have a natural log in your solution. Also forgetting the plus c, a lot of times I see students do that. And also not solving the differential equation for y. That's important to be able to do that. Not all separable differential equations are going to ask you to explicitly solve for y, so make sure you read the question carefully. The next type of differential equation is exponential growth and decay. So this has the form dy dt equals ky. This means that the rate of change is proportional to the amount present. The solution to this is y equals ce to the kt. Now, oftentimes you're going to prove how this formula develops in class, but in actual application on the AP exam, you will not have to show the proof. You want to memorize this solution. Couple important things to note: when k is positive, you have exponential growth. When k is negative, you have exponential decay. That's it for the AB topics. Now let's talk about the two special BC only topics. First one we want to look at is Euler's method approximates solutions numerically using slopes to predict the next point. So here's the formula. The yn plus 1 is the next y value. That's equal to y sub n, which is the first y value, plus f of xy, which is just function notation for the derivative evaluated at that first point, x comma y, times delta x, which is the increment. The steps are you start with your initial point, you compute the slope at that point, multiply that slope by delta x, which is the increment or step size, then you add that to the current y. Then you repeat that process using that y you just calculated as your yn, and then you just repeat the process until you get a final solution. The other topic is logistic models. The differential equation has the form ky times 1 minus y over m. The solution is y equals m over 1 plus a e to the negative RT. You want to memorize this solution. You won't have to go through the proof on the BC exam. You will probably go through that during class though. Here's an example of what a logistic graph looks like. So M is the carrying capacity. You want to know that. You want to know that the logistic model always grows fastest when the amount is equal to half the carrying capacity, or m over 2. Also, the y value is going to approach m, the carrying capacity, as t increases. All right, guys, that's it. Remember, for the AB exam, you need to know differential equations, slope fields, separation of variables, and exponential models. And then BC is going to add to those Euler's method and logistic growth. So if you master those topics, you'll be ready for Unit 7 on the AP exam. Take care.